proportional division theorem in Euclidean geometry. Now, what does the proportional division theorem say? So, generally, when you have got a triangle, let's call that A, B, C, and that triangle has got a line drawn inside it which is parallel to one of the sides. So for instance, let's call this line DE, and DE is parallel to BC. Then the proportional division theorem says that AD over DB is equal to AE over EC. So in other words, they are comparing two sides of the main triangle. Also, that's the first aspect of proportional. That's the first conclusion. Let's go to the second conclusion. You can also have AB, the long one, over AD is equal to AC over AE. You can also have, and they are all proportional division theorems, and you can also have, again I'm going to use AB over DB is equal to AC over EC. So basically, what if you are looking at those triangles? Let's just inspect it for a while and see what is happening. So let's say if I say this one over this one, on the other side I should also say this one over that one. Can you see the top ones over the bottom ones on both sides? And then let's now look again the other one. We can say the long one over the top short one is equal to the top long one over the top short one. And then lastly, we can then say the long one again is over the bottom long one, and the long one again this side is over the bottom long one, bottom short one. Yeah. So that's how you look at the proportional division theorem. Now, let's now get to proving at least some of the theorems. Let's now prove the proportional division theorem. I'm going to take the common proof. So I'm just going to draw my triangle. There is my triangle there. Now, if we have a triangle A, B, C, D, E. If I wanted to prove the proportional division theorem, let's now write down the proportional division theorem we want to prove. Let's take the two short sides. So we're going to have, we want to prove that AB over BC is equal to AE over ED. So we are taking the two short ones, the first one. Now we want to prove, we are required to prove. Now the secret towards proving this is by using the areas of a triangle. Now how do we use the areas of a triangle? There is also one basic fact that we must remember. let us look at that basic fact. If I have got two triangles here, and I've got here. Now, because these two triangles are in between parallel lines, these two triangles have got the same height. So whenever two triangles are in between two parallel lines, they have got the same height. So you need to remember that, because we are going to use that idea. Now, because we are talking about areas of triangles, we take one ratio at a time. So I'm going to start by looking at the ratio AB over BC. So I'm going to deliberately just say, what if I had a triangle with a base AB, and I also had a triangle with a base BC? So let's look at the two triangles. So already I can see this triangle here. Can you see there is my base AB, and the triangle is going to be having a high, and the third side as E. And also I can look at the other triangle, which is going to be having a base BC. But now if I go to BC, the only way I can have a triangle and relate it to that one is by constructing my own triangle, which is this one. Can you see? This is the triangle that I'm talking about. So now I'm looking at that ratio. Now let's look at what is going to happen to these two triangles. They both have bases. In this case, AB has got the triangle ABE. We are now going to have to look at triangle ABE. So we are going to look at triangle ABE and triangle BCE. They both have E in them. And it's very good because it's systematic. So I'm just going to write down area of triangle. Now I start by writing the base A, B, and remember the third side is what? E. You see? Very easy. Divided by area of triangle. I again start with BC, BC, which is my base, E. You see? So you can't really go wrong, because you must make sure that once you've highlighted your base, this letter here, E, is on both of them, isn't it? So now you can't really go wrong with proportional division theorem. Now let's look at our height for these triangles. If I am going to create a height, I will create it perpendicular to AB. The height must be perpendicular to the base of AB. Can you see? There is the perpendicular height. And let's call that H. Now, if that is the height H, it means that the area for this one is half. What is my base? It's AB, and my height is H. What about the area for the bottom one? It's very simple. H is also the height for the triangle BCE. The only difference is this height is coming from E, and because this line BC extends all the way to A, H is also the height. So I'm going to write half BC times height. So this is not very difficult. Now you're going to then say, okay, fine, let's cancel this one. We cancel the half, we cancel the half, we cancel the H, we cancel the H. Then we say, therefore, AB over BC is, so the area of triangle ABE over triangle ABC is equal to AB over BC. So now let's go ahead and look at the other side. Now the other side had has got our AE over ED. Now, so we are going to say area of triangle. We know the base is AE, and this one also, the bottom part, we know it's area of triangle. We know the base is ED. But we want to now look at the other side now. To look at the other side, let's just say we are looking at AE. AE is this side here. Can you see? Now, to have a triangle with AE, it must come to B. So the triangle AE will have a third side which we are going to call B. Now, similarly, if I go to ED, the only way ED can now have a triangle is when it goes to B also. So ED will also go to B. Can you see that? Can you see that? There is a triangle EDB. So we're going to say this is EDB. Now, what about the height? The height of that triangle, let's just construct the height, is going to be perpendicular to ED. So we're just going to draw the height there inside AE. So can you see that? And we're going to call it K. Now, once we call that height K, it means that the area is half AE K multiplied by K over half ED multiplied by K. And also the K will cancel out. You cancel the half, you cancel the K, you cancel the half, you cancel the K, and this will give us AE over ED. Now that's interesting. We've now got the two sides, but how do we make them equal? To make them equal, we must now explain that this area here is equal to this area. And the reason why this area is equal to this area, the area of BCE with the one in green is the same as the area of EDB. So why are they equal? This is because these two triangles are between two parallel lines. Now, if I was to draw a perpendicular line, the perpendicular height between those two parallel lines is that one. So they have the same perpendicular height. Can you see that? So, because you're moving from the line BE going to the line CD, and for both of them, they are touching something on the line CD. The other triangle is touching C, the other triangle is touching D. Now, but if you look at them carefully, you are going to see that they have the same base. So if they've got the same base and they have the same height, therefore the area of BCE and the area of EDB are equal. So let's write that down. Area of triangle BCE is equal to area of triangle EDB. Why? Same base, same height. Once I've said that, I need to write my reason and I need to put it in bracket. Please, if you don't write this reason, obviously the person who's marking your work will have nothing to mark. So that reason is very important. You are now saying that two denominators are equal, and you need to give a reason without showing the examiner or explaining to them about the height. So you just say same base, same height. Now, once we've said that it's same base, same height, we can now then go and make our final conclusion. Our final conclusion will be the area of ABE, area of a triangle ABE over the area of triangle, let's just go back to check, BCE is equal to area of this one here, area of AEB over the area of the last one, EDB. triangle EDB. Do you see that? Once you have done that, you can now then write implying AB over BC is equal to AE over ED. And that's how you prove that aspect of the proportional division theorem. But this is not the only proportional division theorem. Let's look at another one where the long side is involved. So I'm going to just quickly do that one. And we're going to now work very fast. So it's going to be, we've got our triangle. Let's call it P, Q, R, S, T. And Q, T, and R, S are parallel. Now, we are doing the same thing. Again, we are now saying required to prove. We want alongside AR over AQ is equal to AS over AT. Now, again, we are going to start by writing our area. The area of triangle. Again, we have got AR, so our base is AR. We don't know what to add. And then we're going to have area of triangle AQ. Do you see that? But now we need to make it a triangle. To make AR a triangle, I'm just going to make it go to T. Do you see that? So I'm going to make a triangle with AR which goes straight to T. Do you see that? Now, AR, and then I'm just going to, that's a triangle for AR, it's going to be ART. And then the other one, it's AQ, it's just AQT. Can you see that? So I'm just going to add AQT there. Now, if I look at that, I can add my height from AR. For AR, there is the perpendicular height, and this is the perpendicular height of this line here, AR. Can you see that? Now, if that means the area of that one will be, let's call this height K. It's going to be half. The base is AR times K. Now let's look at the smaller triangle, which is AQ. Again, already now the height is already in AQ and it goes to T. So it's going to be over half AQ times K. Can you see that? And then you're going to cancel out. The half cancels, the K cancels, and you're just going to be left with AR over AQ. Now we move on and we go to the other side. We're talking about AS over AT. So we're going to write area of triangle AS, we don't know the third side, over area of triangle. Again, that one is AT, so we're going to put AT. So we need to make a triangle. So AS will make a triangle with R, so we're going to add R there. AS will make a triangle with Q, it's going to make a triangle with Q there. And AT will also make a triangle with Q. Can you see that? So this will make our triangle for AS. Right. Now, once you have done that, you can now then say, this is going to be our, let's put our height inside there. I'm just going to use a green color there. It's going to be on Q. Can you see that? We're going to call that height H. So it's going to be half AS times H over half AT times H. It's very easy. It's almost predictable, so you can actually do it This one cancels out with this one, the h cancels out with this one, and then this will give us AS over AT. Now, the big job is to now explain why these two triangles are equal. Now, obviously, we know that AQT is the same as ATQ. It's the same triangle. But now we need to prove the top part. Now, we need to prove that the top parts are equal. So we're just going to write the same thing. Area of triangle ART is equal to area of triangle ASQ. And what is my reason? It's exactly the same as the one before. Same base, same height. Once I've done that, I am now going to write my formula, and I'm going to write area of triangle ART over area of triangle AQT is equal to area of triangle ASQ over area of triangle ATQ, which will then give me AR over AQ is equal to AS over AT. And that's the proportional division theorem.